This time, we will have inverse function. So, the following are the competencies determine the inverse function defined by a map or a set of ordered pairs. Find the inverse of a function defined by an equation and verify if the two functions are inverse of each other. So, if you are to complete the following table, what do we do? So, we simply substitute the given value of x to the given equation and then so on. So, this is simply 2, this is 5, this is 8, this is 11. How about the second one? Using the given equation, so you have 0, 1, 2, and 3. So any observation with the given values of x and y in the given equation, what can you observe? Okay, okay, so this is the domain of the first function or the given equation. So you have 0, 1, 2, 3, and its range is 2, 5, 8, 11. How about for the second function? Okay, so the domain becomes the range and the range becomes the domain. So you have the domain 2, 5, 8, 11, 0, 1, 2, 3. So this is an inverse function. The inverse of a function f of x denoted by the inverse function of x. If a and b is an ordered pair of the function f of x, then ba is an ordered pair of the inverse function. Observe that if you have an inverse function, the domain and the range or the x and y interchange. Please be reminded that the inverse function symbol is not equal to 1 over f as we denote for a negative exponent. Again, it's not equal. So let's try. Find the inverse of the following function. So you have this one. So what's the inverse? So the inverse is simply negative 4, 0, 1, 2, 1, negative 2, negative 3. Okay, so you have the given inverse. But is the inverse a function? Is the inverse a function? Take a look. 1 is both paired with 2 and negative 2. So this is not a function. So it's possible that your function, the inverse of your function is not a function. Okay, let's try the next one. Is this a function? Or rather, what's the inverse? So we have, so again, inverse, we simply interchange the x and y or the domain and the range. So you have negative 4, negative 3, and 4, negative 9. Is the inverse a function? Okay, it's not a function. We have 4 both paired with 1 and Okay, that's for an ordered pair. So what if the given is an equation? So we have some steps on how to look for the inverse function. First is we replace f of x by y. Second, since this is inverse, we simply interchange x and y and then solve for y in terms of x and then replace the answer by the inverse function symbol. Okay, let's try. So find the inverse of the following function. So following the steps we have, we change f of x to y. So we have y equals 1 over 3x minus 2. Next, we interchange x and y. So you have x equals 1 over 3y minus 2. Then we solve this one for y. We solve it for y. So you have x plus 2 equals 1 over 3y. Multiplying both sides by 3, you have 3x plus 6 equals y. And then the last step is we change y to the inverse function symbol equals 3x plus. So the inverse of the function 1/3 x minus 2 is 3x plus. Next example. So this time you have 2x minus 1, the function 2x minus 1 over 7. So change it to y, interchange x and y, then solve for y. So this is 7x equals 2y minus 1, 7x plus 1 equals 2y. 2y rather y is just equal to 7x plus 1 over 2. So the inverse is plus 1. So this is the second example. Third example, f of x equals x plus 5 over x minus 5. So this is equal to x plus 5 over x minus 1. Interchange. So x equals y plus 5 over y minus 1. Solve. So this is x times y minus 1 equals y plus 5. Xy minus x equals y plus 5. We are solving for y. So we group on one side all variables with y or all expression with y. So this is x plus 5. So factoring y, you have x minus 1 equals x plus 5. So to get y, divide both sides by x minus 1. So you have the inverse as the same x plus 5. Next, so you have number 4, f of x equals x minus 2 is 1 to 1, then there's an inverse. Inverse exists. Based from the example presented a while ago, and in the activity that we have, the domain and range interchange. The domain of the function is the range of the inverse function, and the domain of the inverse function is the range of the function. Again, the composition is equal to x, and the graph of the inverse is symmetric with the line y equals. So again, these are the properties of inverse function. So the inverse function undo each other. So how do we verify if the two functions are inverse of each other? So based from the given a while ago, we have to get its composition. So in the given example, we have this one. So we have to show that the composition of the function and its the inverse is equal to x, as well as the composition of the inverse and the function is equal to x. If both are equal to x, then the two functions are inverse of each other. So for the first one, this is just f of 3x plus 6. Is it equal to? So this is just 1 over 3 times 3x plus 6 minus 2. Is it equal to x? So this is x plus 2 minus 2. So x equals. This time, the inverse of f 1/3 x minus 2. Is it equal to x? So we substitute the function to the inverse this time. So this is 3 times 1/3 x minus 2 plus 6. So x minus 6 plus 6 x x. Okay, x. So therefore, the two functions are inverse of each other. So that's it. Let's have another example. Okay. So to verify again if the two are inverse of each other, we simply get the composition of the function and its inverse. So this is f circle of f, or the composition of the function, x equal to x, the composition of the inverse, and the function of x equals to x. So this means f of the inverse is equal to x. Here, the inverse of x minus 2 over 2 is equal. So we replace x with the inverse. It should be equal to x. So this is negative 3x minus 2 over 2x minus 1 minus 2 all over 2 times negative 3x minus 1 over 2x plus negative 3x minus 2 over 2x minus 1 minus 2, and then 2 times negative 3x minus 2 2 times negative 3x minus 2 over 2x minus plus. Okay, so how do we solve this one? It should be equal to x. So let's just multiply it by its LCD, which is 2x minus 1, right? 2x minus 1 over 2x. So this is equal to negative 3x minus 2 minus 4x plus 2 all over negative 6x minus 4 plus 6x plus 3. So this is equal to is minus 3. Sorry for that. Okay. So that's minus 3. Tama? That's correct. 3 times 2x, 6x. 3 times negative minus 3. So simplifying, this is negative 7x over negative 7. Okay, this time we substitute the function to its inverse. So that is negative 3 times x minus 2 over 2x plus 3 minus 2 all over 2 times x minus 2 over 2x plus 3 minus 1. So we multiply by the LCD 2x plus 3. So you have negative 3x plus 6 minus 4x minus 6 all over 2x minus 4 minus 2x minus 3. So we have simplifying, cancel, negative 7x, cancel over negative 7. So therefore, the two functions are inverse of each other. So to verify if the two functions are inverse of each other, all you have to do is subtract the composition of the function and its inverse, and the composition of the inverse and the function, and it should be both equal to x. To find the inverse function, we have the different steps. Again, first, change f of x to y. Second, interchange x and y. Third, solve for y, and then replace it with the inverse function. So I think that's it for inverse